Hey guys, this is Fozon, and welcome to our long-awaited methods video. I've been foreshadowing this video for a multitude of, other videos that I've used methods in, and I tried to do an introductions to methods video to ensure that you have some basic understanding of what methods do, but now we're going to discuss methods in an object-oriented perspective. And I hope from this video that you understand methods and apply them to your own programs. So with that being said, let's look at the lesson objectives. We're going to first learn what methods are, then we're going to learn the basic syntax of methods, then we're going to learn what constructors are. And I know that you guys probably already know what constructors do because we've developed a bunch of constructors in previous videos, specifically with object-oriented programming or with classes. But we have to understand that constructors in and themselves are methods, but they differ in its method signature. And method signature, if you don't really know what it is, it's how we declare a method, or the basic syntax of a method, rather. So constructors differ from that, and it's important to understand the differences because constructors are ultimately methods. We're going to learn how to construct a constructor, constructor. We're going to learn what about accessor and mutator methods. This will help ensure that we get down the basic syntax of methods because they are heavily dependent on it. They're very simple methods, but they help us practice the basic syntax of methods. We're going to learn about static and instance methods because, well, there are two different things, mainly because of how they get invoked. And we're going to finally learn about method overloading, which sounds fancier than it actually is. With that being said, let's go on to what methods are. Methods in Java. A method is a block of code that executes a function only when it is called or invoked. What I mean by that is methods are certain functions that are contained either in a framework of a class, such as, when we're creating the framework of a class, or in a driver class. And when I mean by a driver class, I mean a main method. A main method is different from what other methods have in that it's invoked by the compiler. The compiler, what it tries to do, it finds a driver class meaning that it has or contains a main method, and in that driver class, it executes the main method first. So we don't personally invoke the main method. The compiler invokes the main method to ultimately allow us to run the program or run the driver class. But when we're creating a framework of a class, otherwise something that we would create an object out of, we invoke the methods through the driver class, and generally those methods are public. Or we can invoke private methods within the same class, and these methods will only get invoked when called upon with the name of the method, or if it it has to also include the correct parameters or correct arguments. And we'll get into what that is in the next couple slides. Methods are utilized inside classes to perform actions and functions. This is very important to understand because methods in itself are functions. That's the easiest way to explain a method. A method does a certain function, and usually the name of the method reflects the context of its function. Let me repeat that. The name of the method usually reflects the context of the function, and the context of the function is what it actually does. So it could be simple as accessing certain instance variables, or it could be or even simpler as just simply changing the values inside the instance variables. Or it could be a little bit more complex. It could be sorting, it could be searching, it could be conducting a bunch of calculations. These all can be done through methods, and generally we will have the name of the method reflect what we do in that method. That will make it easier on us when we're actually invoking it via different other classes or different methods. And it will be easier to, when someone else looks at your code, to see, hey, that's a pretty nice algorithm. You can pass data into methods through its parameters. Parameters, again, are the same as arguments. And you will see them whenever you create a method, you will always have two parentheses after it. And these parentheses can be empty, right? And that generally means that there are no arguments. You're not passing any value to that method for that method to use. But you can also get value so that the method can use those said values. I've discussed that in my introduction to methods video, but we'll do it again just so that we conquer that skill down. Finally, we use methods to reuse code that we want invoked more than once. And that's a very important thing, because if we just simply did a function and then we want to do that multiple times, it would be very hard on us just to code that like 20 different times in the proper location. It's just better to create one method and then just invoke that method, maybe with the proper arguments to have different contexts or have different situations, and it will return us a value, or it would do the calculation for us. It will do the function for us as many times as we want. And that allows us to not reuse code multiple times. It allows us to simply write the code once and then invoke it whenever it is necessary. So let's look at the method syntax, otherwise the method signature. And I omitted the curly brackets, but just understand that after this last parentheses, there's going to be an open curly brackets and a close curly brackets to emphasize, or not rather emphasize, to pinpoint what function or what actual algorithm is being done whenever this method is invoked. But enough of that, let's look at the method signature. First and foremost, we have the access specifier, public, private, or static. Now, generally speaking, static will be paired with either public or private. It could be a private static method, or it could be a public static method, or it could just be static. Now, generally, we will have the value private or public attached with static. So just keep that in mind. But public and private are two different things, as I said in my other video on public, private, and static keywords. The public, if a method is declared as public, that means that it could be accessed by other classes. We can access, if we were to create an object, that has public methods, we can use the driver class to invoke a public method. We can call on this method from another class, aka the driver class. Now, if it was a private method, what happens is that it becomes a helper method, meaning that it doesn't get invoked by a driver class. If another class, a class that is outside of this, if it was a class outside of it, we can't access a private method. Rather, we can't invoke it through simply calling it. If this method was private void add time, I wouldn't be able to call the add time method through another class. I could only call add time method through the same class it was created in, which is why it's called a helper method. It helps the methods in the class, only in the class itself. Whereas public methods can be accessed by other classes outside the class. The second value is void. Now, this is a return type, and we can have multiple return types. Void is just one example of a return type, and we will use this when we don't want to return anything, meaning when we invoke this method, the method is going to do its own calculation, it's going to do its own algorithm, but it's not going to send a value back to the class that was invoking it. Or rather the method that was invoking it. If it was invoked by its own a method in its own class, it's going to not get a value. If it's invoked by a method from another class, it's not going to get a value back. But say we do want to return a value. We want to send a value back to the method that was invoking it. That means that we can replace void with whatever we want replace. We can replace it if we want to send out a word, if we want to send out maybe a sentence, then we can return a string object. And that will send out a string, and maybe they can put the add time method, they can invoke the add time method in a system.out.println line, and then they will invoke this method, and it will print out whatever string value that, well, we send back to the user. And we do that through a return statement. So we will do return and then the value that we send out to the user. It could be a variable, it could be It could be inside a variable, or we could send out an actual value to them. And it's not just simply confined to strings. You can literally return anything. You can return an integer. You can return a double. You can return a boolean. But it's very important to note that when you return these things, that it's reflected within the method header or the method signature. So if I'm sending an integer back to the user, then I need to replace void with int, meaning I'm returning something. And then when I'm inside the method, there has to be a statement that says return and then this integer, and then it sends the integer back, and then whatever the method's going to do with that integer is up to that method itself. But ultimately, for our syntax to work, it needs to reflect, the return statement needs to reflect what's inside the return type of the method signature. So if it's void, it can just simply have return semicolon, or you don't even need the return statement in that case. Or if you have a value there, such as string, integer, double, boolean, then we need to have a return statement that reflects that value. And we're not confined to these simple values. We can return objects for that matter. But remember this, with objects, it doesn't just simply send the value or the values that are inside the object, it sends the memory location for it. And we'll cover that in a bunch of other videos. But I just want you to remember that if you're sending an object, it doesn't make a copy of the object and then send it to the user. It sends where it is on your memory. Remember, when you create an object, it has memory. It allocates certain memory within your computer or within your hard drive or RAM, for that matter. And when you pass it back to the user, or rather back to the method that's invoking it, it simply gives the location of it. So it doesn't create another object and then sends that to the user. It just sends where it is. And that's very important to understand, because it doesn't make a copy. It's just sending you an address. So it's a pointer, basically. Add time, I just put there just for the purpose of, how you generally want to frame a method name. Method names, like I said in the previous slide, it's important to reflect the context of what you have inside the method. And what you have inside the method, try your best to make a method name that makes sense, right? You don't want to make a method name that has nothing to do with what's inside the method, because not only will it confuse you, but it will confuse others as well if they are trying to look at your code or trying to fix your code. And it's very important when you're doing simply algorithmic thinking. It's much easier to just think, oh, this is what the method does, simply by looking at the method name rather than looking at the method function. And then what's inside these parentheses are parameter lists, otherwise known as arguments. If there's more than one parameter, we should separate them with commas. And this is what the other methods send to this method in order for it to be used in the calculation. So if I call add time and then I put, let's say, foson comma 3, then string person gets set equal to foson, and then integer number is going to be set equal to whatever the number I just said. I just lost my train of thought. Most likely 1, right? So then integer number is equal to 1, and then we can use that within our method, and we will most likely use them in our methods because we included them within our arguments. Now, the constructor is a method that is invoked or accessed when an object is being created with that class. And the constructors are different from what the regular method that you already got used to. And these will generally reflect the name of their class and will have the word public right beside it. And this makes it very easy to spy. It's very easy to find the constructor when you're looking at a framework of a class. If you're looking at a class that is acting as the framework for an object, because you simply look at the class name and then you find the class name as a method within the class. So very easy to spy. There's no return types. And your constructor can have arguments, and this allows us to instantiate the instance variables. You allow yourself to have values within your instance variables. And Java actually creates a default constructor when you don't make your own constructor. So when you don't make your own constructor, what Java does is that it creates its own constructor, and then the instance variables get their own values that it instantiates with. And it's less amusing than you think it would be, but nonetheless, it's very important to emphasize. So let's take an example of a default constructor. I created this class called public class student, and this will serve as the framework of our object, a student object. And I have a comment, so remember that double slashes mean comments, so this is omitted by the compiler. And we have two instance variables. We have a private string name, and we have a private int ID. Notice that we have no constructor, a method that has the name student, or public student for that matter. No method literally in this class. And, well, no way to actually create it. But little did we know that Java creates its own default constructor. So we can go into the driver class, because the driver class has a main method. So what happens is the compiler invokes the main method, and you don't have to worry about the arguments within the main method. And it creates a student object. Student stud is equal to new student, and we have no arguments because, well, the default constructor doesn't have any arguments. And what happens is that Java actually compiles this, and it says, hey, we don't have a constructor, and we have no way of actually, well, creating this object from what the user wants, so we're going to create it ourselves. So it creates a student object, and it allocates certain memory for the string and the integer. And then the value that gets set in name will be null, null meaning that there is nothing there, right? So it's null. That's actually a Java keyword. And in ID, it's just going to simply store 0. Now, we can generally override the default constructor, and we want to do this in scenarios where the default constructor provided by Java is not suitable for our needs. Say, for example, that if we let Java do our own default constructor, what happens if what happens if maybe we have a person named null, or we have an ID of 0? We don't want that to clash with we don't want the default constructor to clash with what is already within our database or within our system. So in that case, we create our own, we don't create our own default constructor, but we create our own constructor that doesn't have any arguments. And as you can see, we have our instance variables, private string name and private integer ID. And we also have a public student, which is going to serve as our constructor. It's very easy to spot because, well, if we omit public, we have the name of the class with parentheses, implying that it's a method. And this method is a special type of method, aka the constructor. And what we do is, instead of setting name, well, automatically to null, we set name equal to unavailable, because I highly doubt anyone's name is unavailable. I'm sorry if your name is unavailable, but that information is unavailable to me right now. We also have an ID of equal to -1, because in our school system, nobody has an ID in the negative numbers. We have only positive numbers as our ID, and we don't want the ID of 0 to be clashing with the default constructor. So we create our own constructor that sets an ID equal to -1 when no one provides any arguments. And we have our constructor with, well, arguments. I have constructor with constructors as my method name, mainly because I have two constructors, and we have a multitude of constructors. Java will handle it no problem, but we have to remember what actual constructor gets invoked when we create the driver class, aka the main method, the class with the main method. So we have public class student, and instead of just one method, we have two methods. One method that overrides the default constructor, and a method that contains a string n integer number, meaning it has arguments that allow us to set a value to name and ID. And when we call student stud equal to new student with the arguments Dave and 6, then what happens is that instead of calling this method, it calls the second method. Public student string n integer number. The values Dave go into this argument. The value 6 goes into integer number. So string n is gonna be equal to Dave. Integer number is gonna be equal to 6. And then we have values for our name and ID, because name is going to be set equal to n, meaning name is going to be equal to Dave. ID is going to be equal to number, and number is 6, so ID is equal to 6. Accessor methods are special type of methods that return, not necessarily special type of methods, but they are methods that return a class object without changing it. Ultimately, we don't want to change with accessor methods, we don't want to change values within the class. We just want to access them and see what values are actually there. And the goal of using an accessor method is to get information regarding the object. And when we're creating the object, or when we're creating accessor methods, we will have no parameters, meaning nothing within the parentheses, and we don't specify when we do have a return type. So this is very important when we discuss mutator methods, because accessor methods and mutator methods are two different things, and they're very easy to grasp once you know what they ultimately do. So just remember, with accessor methods, remember this: no parameters, there is a return type. No parameters, there is a return type. Okay? So let's look at an accessor method. So we have public class student, private string name, private integer ID, and we create the object with our Dave and value number 6. And then we have a public string get name. Public is emphasized, or rather telling us that, or telling the compiler for that matter, that we can access this method by another class, and this class is student client, or the driver class. So we can access this get name method. Get name is the method name, and that's how we call the method. So when we access it, we're going to access it through get name, and it's going to return a string. So there's no void. Void implies that there's no return type, but we do have a return type with accessor methods. So it's going to be a public method. We can access it. It's going to be returning a string, and we access it through get name, and there's no arguments. So remember, no arguments, yes return types. No arguments, yes return types for accessor methods. And what it does, it has one statement: return name. Okay, so now when we look at the driver method, a driver class, and then the main method, we create an object, Dave6, and then the way we access the get name method is by doing stud, or the name of the class that we did. So we created the object. When we created the object, we created the object with the name stud, and we want to access the get name method of the stud object. So we call stud, and then we get name. And since there's no parameters, we simply just have these open and close parentheses. And it's important to emphasize that we have to have, no matter what method that we call, even if it has arguments or not, we will have parentheses when invoking it, simply because when we invoke it, this will tell the compiler that we're actually trying to invoke a method. Without any parentheses, regardless of whether or not if it has arguments or not, what it's going to try to do is find an instance variable with the name get name, and we don't want to do that because get name is a method. It isn't an instance variable. So what happens is that it accesses this method. It's like, alrighty, I'm looking for a string. Do we have a string? Name. It says return name. Let's look at name. Name is a string, so there's no compiler issue there. And it accesses the value at name. So in this case, it's going to be Dave. So Dave is inside the word name, or rather the string name, and it returns Dave back to the compiler, and then it prints out Dave. Now, mutator methods are unlike accessor methods, and it's exactly how it sounds like. We'll change the state of an object, right? Whereas accessor methods simply check the state of the object, mutator methods will change the state of an object. Ideally, one of the instance variables will be altered, so we don't want to be changing multiple instance variables with one mutator method. We will have a mutator method for each instance variable, just like we'll have a accessor method for each instance variable. And generally, we'll use one argument to get the new data. So remember this. Remember the reason why we have an argument parameter is so that we can get the new name or to get the new state that we want for that object, get it through another class, and then set that as the new value. So to remember mutator methods, remember yes arguments, no return type. So you're not returning anything, so it's going to be void, but you will have parameters because you want to change the state of an object. And how do you access that new value? How does that method rather get that new value? It gets it through an argument when it's being invoked by another method. So we have a mutator method. I have the same class again, but instead I have both a getName method. The getName, as I said before, is an accessor method. But now we also have a setName method. Again, we're reflecting in the context of what happens within the algorithm or what happens within the method. So we have public, meaning that we can access it through another class, which we can, right? We're accessing the setName method. We have a void, which means that we're not returning anything. And if we have a void, we can have return semicolon, and that just simply ends the method right there and then goes back, right? But if we have other things after the return statement, then we don't really need a return statement for void. So just for the sake of, well, using return statements, just know that if you have a return statement in a void, if it has a value, that means it's wrong. But if it doesn't have a value, then just end the method right there. It doesn't even look at what happens after the return statement. But in this case, we don't have a return statement for the void method. And that's because, well, we're simply just setting the value of name, the instance variable, equal to the value that we get within the parameters. And when it gets invoked, when it gets invoked, it's going to be invoked by setName and then whatever the value that we want name to be. So let's look at our client or driver program. In our main method, we create the object with the name Dave A. And I omitted the numbers because it doesn't really, it puts too much in the program that's unnecessary. And we simply want to look at what actually happens when we use the setName and accessor method. So we do student stud is equal to new student. So we have a memory location that contains an object, and in that object it contains a string name, and in string name we put Dave A. And when we access this memory location, we access it through stud. In stud, we have a method called setName, and we no longer want the name Dave A within the object location or within the object stud. So we invoke the setName method of stud, which is inside the student class. And when we invoke it, we need to put in parameters. So when we access it, we access through its name, the object's name, stud. Then we access the method name that we're trying to access, so which is setName. We have open parentheses, and since there is a argument, we need to have a value within the parentheses, unlike the accessor method, which we can simply leave as an open and close parentheses when we're invoking it. So we have David A in quotation marks because it needs a string value. We can't put David A unless we have David A as a variable name as well, as a string variable name. But for this sake, we're going to be sending the string David A. And to emphasize that it's a string, we have the double quotation marks, which tells the compiler that it is ultimately a string and not a variable that it should be looking for. So the value David A gets sent into stud's setName method, and it takes in the value. So it's like string cool is equal to David A. And then it says name, so the name that's used in its instance variable is equal to the value of cool. Well, the value of cool was David A. So what happens is that name gets now set from Dave A to David A. So Dave A is no longer a thing within this method. Name is now going to be David A. And then when we access the getName method of the stud class or the student class of stud, because it has its own getName method, we access it with the double parenthesis, with the open and close parentheses without arguments, because the accessor method contains no arguments, and it sends us back a value. The value is our name for the class or the name of the student, and it prints the value out. And that value is David A. Let's go into the compiler to test comprehension. So we're in the compiler, and we want to make values for each and every one of these. Now, I'm not going to go over every single one of these values, but I'm just going to help you get started by creating four methods, two of which are going to be accessor methods, and then two of which are going to be mutator methods. So, as you can see, we have a demo class set up, and what the demo class does is that it creates 3 students, and the students' name are Tony, Fauzan, and Vic. And then it invokes the getDetails method of each student. Like I said in our constructor takes in those arguments, and then it sets that as the values of our data fields or instance variables. And then we have a method called public void getDetails. And as you can see, it's named void. For what reason? Yes, there are no return statements or a return statement that returns a value. But we can change that. We don't want to simply, what if we want to access simple values of this? We don't want to have all these values being printed, and we want to send it back to the student demo class or the client program. Well, we create accessor methods for that. So to create an accessor method, let me comment this and then do accessor methods. I hope I spelled accessor right. And when we're creating an accessor method, it needs to reflect what it's actually being accessed. So the return type that we're going to first do is string. What if we want to access a string? So we do public string get, and what are we accessing? The first name. Or what, let me do this actually. What we could do is we could do public string get name. And what we'll do is we will return the first name and the last name. And there are no parameters because we are accessing the method. We're not setting anything, so it's not taking any values. Let's open the parentheses, and then we're going to close it. Okay, good. So now let's create a string name and try to concatenate both the first and last name. String name is equal to first name space last name. So now what this does is that it combines the first name and then it creates a space and then has a last name. Then what we're going to do is we're going to return the name. Now let's access this method within the client program. I'm now going to just make these comments. That way we can only focus on what we need. So what we can do is, well, we can do two different things. We could do system.out.println, and what it does, it's going to do first student, and within the first student there's a method, a public method that we can access called getName. So we can do getName, and remember to have the open and close parentheses because it is ultimately a method. So when this gets invoked, it's going to return the name, Tony space S. Compile. And let me make sure that this is saved as well. And let's run it. And it prints out Tony S because it concatenates first name and last name of that object. This accessor method concatenates it and then returns the name. And then when it returns the name, it gets sent into this println statement, and the println statement prints Tony S. We can also store these values within a string. So we can create a string, and we can do string name is equal to first student dot get name. And what happens is that get name, well, Tony S gets stored into name, and then name gets printed out within, sorry for that voice crack, gets printed out in the println statement. And we get the same result. It's just that we have another extra line, a middleman. But we can use that middleman in a multitude of locations. Let's try this with a different return type. We can try this with private integer grade level. And the reason why we have accessor methods, by the way, I don't know if that was made clear, is because these instance variables are generally private. We're hiding information with private instance variables, and we don't want it to be accessed directly by its name. So we have methods set up to access it. So let me return the rank. And the rank is an integer. So we have a public method, and the return type is going to be integer. As you can see, it highlights because it is a primitive type, or a rather Java keyword that it recognizes. And what we're going to do is get rank. Reflects the context of what we want to return. Then we have open and close parentheses, and then open and close curly brackets. And then this is simply just going to do return whatever the value or whatever the name of the variable is, and it's going to return rank. Let's save that. Let's compile it to make sure there's no error. Let's look here. Let's create a print statement that accesses the accessor method. So first student, and the first student has a getRank method, and the getRank method I believe should be 1, I want to say. Yeah, so the last value is the rank. So it should hopefully print out 1. And it prints out 1. Again, we can create an integer. It's no problem. Create an integer rank is equal to then whatever we get from this method. And then when we print out rank, right, it should print out 1. Same thing. But we have a middle person that stores the value of what we get from this getRank method of the first student object, and then prints out rank. Let's make a bunch of mutator methods and see whether or not if that actually changes the value. So I'm going to do it for the same name and getRank. That way we can use it concurrently with our mutator methods. And again, hopefully I spelled mutator methods wrong. Hopefully I spelled it right, not wrong. So we want it to be accessed by other classes, but instead of returning something, we're not going to have a return statement. So what we're going to have is a void. And then to reflect the context of what we want to do, we're going to have set name, because we want to set a new name. Now, in this value, we're going to have a in our parameters, rather, in our arguments, or within these parentheses, we're going to have what we call arguments. I'm repeating myself. We're going to have values that we can set as the new name. So since name encompasses a first name and a last name, we're going to try 2 parameters. String first name. Actually, I'm going to name it fnum because I haven't taught you scope. So I'm going to do a string lnum because we don't want the values names here to interfere with the values over here. Okay? And once we get those values, we should have f first name equal to fname, sorry. And we're going to have last name equal to lname. Right? So the instance variables here are going to get new values. And these new values are the values that we put within our parameters. And I'm also going to do the same with rank. So public void, because it's not returning anything, and then set rank. And it's going to get an integer because rank is an integer, and it's going to get a new rank. And then set the value of rank, since the instance variable name is rank, to the value that is in the parameter. Okay, so that works. Let's compile to see if there's any issue. There's no issue. So let me access these methods. System.out.println, and what we're going to first do is we're going to access the getName method, and then we're going to do the same with rank. Now what I want to do is set new values. So what we're going to do is we're going to call first student, and then first student is going to have a set name method, and instead of having Tony, we're going to have Captain America. And instead of a rank of 1, he's going to have a rank of 2. And the reason why this has two arguments is because it reflects the 2 arguments that I've already set for this. But this is a very rare scenario to have 2 arguments, and generally you want to avoid this. So you will most likely need a set first name and a set last name method. But I'm showing you it is possible to have maybe 1 or 2 arguments. But generally you'll have 1 argument that has it for one that reflects the context of 1 instance variable. And then we're going to recall this method, these 2 methods again, to see whether or not if they've actually changed. Let me compile on this end to see if it works. It works. Let me compile on this end to see if it works. It works, and let me run it. And as you can see, what happens? We have a Tony S when we create it, and when we access the name, it has Tony S stored there. It also has the rank of 1 stored here because that's what we had as the value initially. And it prints out, respectively, Tony S and 1. Then we set a new name, Captain America. We also set a rank of 2. And when we access the methods again, it prints out Captain America and 2, the new values that we set. So it shows not only do our accessor methods work, but also our mutator methods, aka our setter methods, work too. Let's go back to the presentation. Static methods versus instance methods. So constructors, accessors, and mutators are all instance methods because they all operate on individual objects of a class. Whenever you create an object, it's going to have its own constructor, it's going to have its own accessor methods, it's going to have its own mutator methods, so that when it invokes it returns or sets its respective instance variables, because instance variables, those specific instance variables rather that don't have the static keyword, will have will be its own respective of the own object. The object is going to contain its own instance variables that are able to be changed through these instance methods. However, a static method, unlike these instance methods, are shared by all instantiations of the class, meaning that all classes share this same method. It's not special. Basically, what I'm trying to say is that they all share this one method if there is only one static method. But if it's a static method, just know that's only stored once in the compiler, and it's stored once in the hard drive, and all the all the methods or all the instantiations of the classes or all objects use that same static method. It's only located once in one location. Whereas every time you create an object, it's going to create its own instance methods, its own respective instance methods that get invoked when its own respective instance methods get invoked. And if you call a static method, by the way, it's not invoked by by a object name, it's invoked by the class name. Again, a little bit more into that later, but a static method is ultimately done for the entire class, not just the individual object itself. And to recognize a static method, it's just like a static instance variable in that you can recognize it easily with the static keyword being used. So let's look at an example of the static method in use. We have a public class student we have a private string name, we have a student count, and the student count value is a static variable. So if you have a static variable and we're trying to access a static variable, generally the method that we access the static variable in will be a static method, right? Because we want to reflect the static context. And we have two methods. We have we have two constructors. We have a constructor that has no arguments and a constructor that has one argument. And either or, what they do, both methods, what they do is that they increase the student count by 1. Student count, just to remind you, is a static value. And when we access the static method, get student count, it returns us with the number 2. Because we create two student objects, and whenever we create this object, what happens? It increments the value of student count by 1. So when I created this object, student count gets incremented by 1. This is no longer 0, this is 1. When stud2 gets created with the empty, no argument, the empty constructor, it still increments student count by 1. So now it's going to be 2. And just to remind you, static variables are just like static methods. They're only allocated once, right? Every time we create an object, it doesn't create a new student count. It simply just uses the same student count that it uses for all classes, the same memory location. And in this case, every time we create an object, it increments the value of student count by 1 to tell us how many student objects there are, which is a very good use for it when you're creating other objects or creating your own programs. But just for the sake of right now, we have student count being incremented whenever we create an object. And we set this to private, meaning that we can't access student count by simply calling it student count. We have to create a public method that can be accessed by another method, by another class, that can return the student count, which we did. Public, which implies that, hey, we can access it through another method. Static, meaning that it's shared by all instantiations of a class, not that another copy of it is being created every time we create an object. There's only one memory location for it. We have it returning an integer. So it returns student count, and student count is an integer. So integer is going to be within our method signature, not void. Then we have get student count. Get student count is the name of the method, and again, reflect the context of what happens within the method. And we have the open and close parentheses. Since this is an accessor method, we're not going to be taking any parameters. We're simply just going to be returning a value. And static methods don't have to simply be used just for accessor purposes. You can run its own calculations and return something for that matter. The math class, I know, uses that a lot, which we'll get to in another section, but ultimately static methods, we're simply doing something that any class can use irrespective of what's inside the class. So we have this value student count. It's static. We don't even have to create an object to access this value through the get student count, but just for the sake of showing you how it works, we created two student objects. This gets incremented twice, so now it's going to be 2, but since it's private, we can't access it directly, so we use the print statement and then we access it student. It's not going to be accessed by the names of these, just like the other methods, unlike the other methods rather, that are not static methods. What we do when we're accessing static methods is that we access it through the name of the class. And the name of the class is student, and then we do get student count. So it goes to student and it accesses get student count. Technically speaking, we can have a class or driver class that only has this statement, system.out.println student.get student count. And what it will do is it will do the exact same thing, except it won't have these two statements that increment the value of student count. So what it will do is that it will print 0. In that regard, if these two statements weren't here, it would still print this, because this gets allocated simply when we have the object there. So we've created the framework of the class, and we've already created that student count is going to be equal to 0. So it's just going to access that student framework, and it's going to be like, alrighty, that's 0. But we have two student objects created, and it's going to reflect that when we access the get student count, which is ultimately 2. And you can try to do this on your own student class, and just for the sake of time, try implementing this within the student class on your own compiler. For the final rather lesson objective of our methods video, it's method overloading. And again, just like I said in the beginning, it's more fancier than it sounds. Overloaded methods are methods in the same class that share the same name. But the difference between these two methods is that they differ in that they have different parameters. So if I had to sum up method overloading in 4 words, it would be same name, different parameters. Same name, different parameters. So how does the compiler differentiate what method to choose? Well, when you're invoking the method, it's going to look at what arguments match what method we want to look at. So let me provide you an example to make it more easier. I omitted the class name, but understand this, the class name is simply student, the same class name that we've been using throughout this entire video. So we have a private string name, and it's not declared automatically. We have a private integer ID, and again, it's not declared automatically. We have a public void change details, string cool, this is our parameter list. So this you could say is, this is going to be, change details is going to be our method name. So whenever we invoke it, it's going to be called by change details, but it's going to have one parameter. And all of these are mutator methods, so they don't return anything to the user. And in the method signature, it reflects that it has no return type by having void within the method signature. So we're not returning anything. We're just simply setting or doing our own algorithm to change the value that's stored within name and ID. So we have a change details method with a string, and what this string does is that what this method does is that it changes the name, and it changes the name to whatever is in the parameter. So name is going to be set equal to cool. So whenever this gets accessed, it's going to set the value equal to, then it's going to be string cool to whatever the value it gets, and then whatever the value we get is going to be set equal to, is going to be put into name. We also have a public void change details integer number. So this is the exact same method signature as the previous method, except it differs in its parameter list or arguments. And instead of having a string, we now have an integer. And this integer is going to be, this method gets an integer from another class or another method rather, and then it will use that number to be placed into ID. And the third method, again, has the same method signature, except it has 2 arguments this time with both string and integers. And when we have string and an integer being passed there, it's going to put it respectively in its respective instance variables. So we have a client class. Again, client class means what? It means that it has a main method. In the main method, we have created a student object. So what happens when we create a student object with the default constructor? Meaning we don't create a constructor. So that means that Java creates its own constructor. And in that regard, what happens? Name gets set equal to null, right? Meaning that there's really nothing there. And then ID will be set to 0. So if we were to cut off the program here, if I made these 3 statements comments and just had it like this, name is going to be equal to null, ID is going to be equal to 0. Alrighty, so now we're going to do change details. So it's going to be like, alrighty, change details. What method do I look at? It's going to be, alrighty, change details. We found a change details method, but it takes a string. And do we want to do that? No, not really, because, we have an integer, and that's not going to work because it wants a string. Let's find another method. Maybe we have another method in our program that has an integer argument to avoid, any error. Because if we didn't have a method that had an integer argument for this respective method name, then it's going to hit us with an error because that's not possible to do. So change details. Alrighty, we found the second method. The second method contains an integer argument, and just an integer argument, meaning that this will work. So what happens? 5 gets sent into this method, and then integer number is going to be equal to 5. ID is now going to be equal to 5. So up to this point in the program, name is going to be equal to null because we haven't done anything with the name. and an ID will be equal to 5 because we changed it through the change details method with only one integer argument. Let's look at the second statement. The second statement, what it does is accessing the change details method, but this time it has two arguments, a string argument and a integer argument. So it's going to look at the first one, change details string cool. We don't have a string, we don't have two arguments here. So we're going to look at this one. We don't have two arguments here either. So we're going to look at this one, this other change details method. And we do have two arguments. Are they the same variable types? Well, we have a string here and we have an integer here. We have a string here and we have an integer here. So this method works. This change details method works because we have the method name and the same argument types. So Omar gets sent to string cool. So string cool is going to be equal to Umar, and then integer number is going to be equal to 18, and then that gets plugged into name, and then ID gets equal to number. So name is now going to be Omar, and then ID is going to be equal to 18. So up to this point, we no longer have name equal to no. We have a name equal to Omar, and ID is going to be equal to 18. It's going to be no longer 5. And then finally, we access the change detail method one last time, but this time we have one string argument. So that's going to fit here because we have a one string argument here. And we just wanted to fix a minor correction on Omar. So what happens? It sends Omar to string cool. String cool is now going to be equal to Omar. So name is now going to be equal to Omar because name is equal to cool. Cool is Omar. So name is now Omar. So after this entire program gets executed, name is going to be equal to Umar, right, with the capital U, and then ID is going to be equal to 18. And that is basically how to overload methods. And that should be the entirety of what we're going to be doing with methods, particularly in future videos as well. Methods will stick with us throughout the course of not only this class, but whatever computer science class you go into. It's very powerful, and having a good understanding of methods will make you a very, very powerful programmer. Thank you for watching.